Okay, right here on the warm-up, it says find the area of the given rectangle. First off, how do you find area of a rectangle? You multiply. You take length times width, right? So we're multiplying these two. So you'll take 9 times 4. 36, right? Then I have 1x and 2 x's. X to the third power. Remember, when you're multiplying the bases, you add the exponents. Then I have 2 y's and 1 y. Y to the third. And you only have 1 z, so you just add the z on there. And that's your answer. Shouldn't be anything difficult after working with exponents. Okay, what we're going to do is we're going to start working on simplifying radicals. Okay, we've done it, we've pressed it a couple times. That's when we have that square root sign. We've seen that when we've done the quadratic equation. Okay. Now, first off, you guys should have your notes page. Okay, you should be able to follow along and fill in the blanks. First off, this right here is the radical sign. And the number that's inside there is called the radicand. Radicand. Okay, make sure you have those down. This means the square root of 16. In other words, what number can you square to get 16? Okay? The square root of 16 is 4 because 4 squared is 16. So basically, instead of like how we do 4 squared, the square root's going to be the opposite, right? So 4 squared is 4 times 4. That gives us 16. If you take the square root of 16, you're trying to go backwards. Now it says when the radicand is a perfect square, you'll get a whole number answer. Underline right there, a perfect square. Okay? When you have a perfect square, again, you get the whole number. Now this is what I mean. 1 squared, remember that means 1 times 1. 1 squared is 1. 2 squared, 2 times 2, that's going to give us 4. 3 squared, 3 times 3, 9. 4 squared, 4 times 4, 16. One of the biggest mistakes with these squares right here is people try and do like 4 times 2 and tell me it's 8. Remember, that's not what it means. 5 squared means 5 times 5. 25. Yeah, I think the 6 is down there, right? There we go. 6 times 6, 36. Over here, 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. 11 times 11, 121. And 12 times 12, 144. Just like we just multiplied together to get those, if we go backwards and take the square root of 64, the square root of 64 means what number times itself gives you 64? 8 and 8. Okay? All right, let's go to the next part. So, for example, like what I'm saying right here, the square root of 49. If I go back here, 49 is right there. If I take the square root, it's 7 because 7 times 7 gives me, oh, I went backwards again. There we go. The square root of 49 is 7. The square root of 25. is 5 because 5 times 5 is 25. Square root of 121, 11. These are called perfect squares because they come out to be even numbers. And it'll be whole numbers. It'll be not even numbers, but whole numbers. You're going to end up finding out in just a second. Some of these they'll be decimals, but a lot of times we're going to leave them as in the radical form, but we're going to learn how to reduce them. Why do I keep going backwards? Try again. All right. When the radicand is not a perfect square, you can, 1, simplify the radical, or use your calculator for an approximate answer. Okay, we're going to use a factor tree to pull out the perfect squares. All right, so here's what we're going to do. First off, I need to figure out what numbers give me 720. Now, off the top of my head, I'm sitting here looking at it. I know it's even. You can use a 2. So we can go back to the factor tree. You can use a 2. I also know when there's a 0 over here, I can do a 10. So I'll start with doing 10 times 72. And if you don't know, if you don't know where to start, just take 720 in your calculator and press divide and use some number and see if it comes up to be another whole number. And especially if it's even, you can use 2. It just takes a little bit longer on your tree. 10 splits up into 2 and 5. Those are prime numbers. That's as low as those can go. 72. What's 72? 9 times 8. Okay, well, those, I can still break those down some more. How does 9 break up? 3 times 3. What about 8? 4 times 2. Are they all in prime numbers? No, I need to break up 4. That gives me 2 times 2. Okay, now, to kind of write this out to make it a little bit easier, let's see. I'm going to take this. Instead of writing 720, I'm going to do this. I'm going to write 2 times 5. Okay, so I did those. 3 and 3. Just be patient with my madness. 2 times 2 times 2. So that was these 1, 2, 3. All right, looks like I've got them all. You're going to think of this radical sign as a house. Okay, you can only go outside and play if you have a partner. If you have somebody to go outside and play with. Okay? So the 3s, they have partners, right? So these 3s can go outside to play. So a 3 will go outside. Are there any others that have partners that can go outside and play? The 2s can go outside and play. What about something else? Another 2. They have partners. They can go outside and play. What about the 5? 5 has no friends. 5 has to stay inside and play. Now, everybody who's outside, 2 times 3 is 6. 6 times 2, 12. So this is going to be 12, the square root of 5. That's your answer in simplest forms. So the square root of 720. Whoa. Square root of 720 can be reduced to 12 square root of 5. Okay? Let's see what this is on the next slide here. Okay, so using a factor tree to pull out the perfect squares, what it says is here, Oh, I didn't even think about doing it that way. I guess if you would have figured it out right away, you could have seen that. I like my way better. Anyway, that's all right. So they split theirs up. They do 5 times 144. I never would have guessed that. And then if you would have split it up into, basically they're splitting it up like the square root of 5 and the square root of 144, right? Square root of 144 is a perfect square. That's where they came up with their 12. So then that's how they got 12 square root of 5. You're going to see me using the house and stuff because I think it's easier to break it down that way. Okay, checklist for simplifying radicals. First, you want to figure out if the radicand has no perfect squares left. The radicand has no fractions. There are no radicals in the denominator. And we'll get to that later. All right. Now simplifying. Let's start with the square root of 75. I'm going to do it on a different slide. All right, so let's start with 75. Whoa, what am I writing? Let's split this up. Okie dokie smoky, let's see. I know 5. Anything that ends with a 5 should have 5 on it. Okay, so 5 times what, though, is 75? 15? And some people, if you're saying, how do you get that? Take 75 in your calculator, divide it by 5. Okay? 15, how would that split up? 3 times 5. Now, these are all prime numbers, right? That's as low as you can go. Okay, so inside the house, I have 5 times 3 times 5. Is there some friends to go outside and play? The 5s can go outside and play. They have buddies. So the 5s get to go outside. What about the 3? 3's grounded. This is as low as it goes. It's 5 square root of 3. Now, one of the ways they could have done this, how they were showing like that perfect square thing. 75 breaks up into 25 and 3, right? Well, that's the square root of 25 times the square root of 3. What's the square root of 25? 5. So that's another way. If you can see the perfect squares in it, you can do it this way as well. If that works, if there are perfect squares in there. What was the next problem? 45. Okay. Square root of 45. I'm going to do a factor tree. 45. Well, I'll do 5 times 9. Couple ways we can look at this right now. We'll still do my way first. 9 splits up into 3 and 3. 5, 3, and 3. 5 times 3 times 3. Who can go outside and play? The 3s can. So the 3s will go outside and play, and who has to stay inside and do the laundry? The 5s do. Now, this is the answer. So if you saw this from the beginning, right? When I split it up as 5 and 9, square root of 5 and the square root of 9. What's the square root of 9? 3. Is 5 a perfect square? No, so it's square root of 5. It'll give you the same thing. It just depends on if you see the perfect squares or not. All right, next one. My pen, there we go. 200. All right. 200. What? 100 times 2? Now, if you wanted to, do you see a perfect square already? 100 is a perfect square, right? You'd have the square root of 100 and the square root of 2. What's the square root of 100? What times itself gives you 100? 10. It would be 10 square root of 2. That's one way to do it. Now, another way, remember, is to take 200, and I know 2 and 100. 100 splits up as, well, I guess I could do 2 and 50. I don't know why I wrote 2. This one would be 5 and 10, 2 and 5. So I would go to the house, and I'd have 2 and 2, and 5, and 2 and 5. And then who can go outside and play? The 2s can, and the 5s can. Who has to stay inside? The 2s. Well, what's 2 times 5? 10. So again, 10 square root of 2. Exact same answer. Again, sometimes it just depends on if you can see this. Okay, so now simplifying. I have 5 square root of 18. Guys, go and do the house right here and split up 18. How does 18 split up? 9 and 2? How does 9 split up? 3 and 3. These are all prime numbers, so I'm done with trying to break it down. So I've got 5 square root of 3 times 3 times 2. Who gets to go out and play? The 3s do. So a 3 goes out here. The 5s are already out there chilling, say, come out and play hide and go seek. Okay, I know I'm mental. It's okay. All right, and the 2s are still inside looking out the window saying, I'm grounded. This sucks. Okay? Now, 3 times 5 is 15, and the 2s are still inside. So from here, simplifying this, it is 15 square root of 2. Take a minute and try and do number 5. Okay, on this one, let's move it down. I have a, I'll get all that other stuff off of there. Let's see here. 2 square root of 150. Okay, so 150. In my mind, I'm sitting here, and it doesn't have to be the same things. You break yours up as long as at the end it's the same. I'm thinking 15 and 10. If you did something else, that's fine. Just wait till the end. 15 splits up as 3 and 5. Okay, those are prime numbers. That's good. 10, 2, and 5. Okay, so let's come back over here. I've got 2, and inside the house, I've got 3 times 5 times 2 times 5. Who has a partner to go outside and play? The 5s do. So the 5 gets to go outside and play. And the 3 and the 2 have to stay inside, right? 5 times 2 is 10 square root. 3 times 2, 6. Okay. Oh, come on now. All right. Now, when we approximating radicals, when you estimate the value of a radical, and then we're going to verify it with the calculator. Okay, so sometimes you can look at it and figure out what it approximately is. See, the square root of 10 is going to be just a little more than the square root of 9. What's the square root of 9? 3, right? Because 3 times 3 is 9. So that means that the square root of 10 is a little more than 3. In your calculator right now, press second, the square root button, put 9 in there and press enter. Some of you are like, I don't know where my square root button is. Well, let me help you with that. It might show up here eventually. All right. You press second, the x squared button, and 10. 3.16. So again, that's a little more than 3. So if you had to do some estimating, that's what you'd be looking at. Okay, so right here, let's talk about how we guess through this a little bit. Don't put them in the calculator yet. Square root of 19. Let's think of perfect squares that we know. 9, there's 4, 9, 16. What comes after 16 is 4 times 4. Between 4 and 25. So, or between 16 and 25, what is that close to? It's close to 16, right? So my guess would be about 4.2. I don't know. That's the reason why I did a lower number was because the next square root is 25. And it's not real close to 25. So let's try. Let's go to the calculator. Put in there the square root. Square root button of, what do we have? What number was that? 19, sorry. There you go. What did it end up being? Yeah, 4.3 or 4.35. Say it'll be just fine. Let's see. All right. 4.35. Try that on the next two. Try that on the next two. Let's see how we do. All right, talking through 24. Think of your perfect squares. 2 times 2 is 4. There's 4, 9, 16, and 5 times 5 is 25. Okay, this is not quite 25, so it's got to be just a little bit lower than 5. So I'm going to guess 4.9. So when I go here, I'm going to press square root of 24, 4.89. Or rounding up, it's 4.9, whatever, that's fine. You're just trying to get close. 51. Okay. 25, 5 times 5, 6. 6 times 6 is 36. 7. 7 times 7. 7 times 7 is 49. That's close to 49, right? Just a little bit bigger. So I'm guessing 7.2. So I go to my handy dandy calculator. Put in there second, x squared. I'm going to put in there 51. 7.1. Okay. All we're trying to do is estimate, seeing if we can get close to it. Now it says how to multiply radicals. Okay. Both of these numbers are underneath the square root sign, right? They're inside the house. Inside the house is 3 times 2. Do any of them have friends to go out and play? No. So multiply them together. What is 3 times 2? 6. You have the square root of 6. That's all it is. If they don't have a partner to go out and play, that's all you can do. The next one, 25 is already outside. And you have 2 times 2 inside the house. Can anybody come out and play? The 2s can because there's partners, right? So you bring the 2 out here times 25. There's no one left in the house, so the square root sign goes away. What's 2 times 25? 50. So your answer would be 50. Now this one says how to rationalize a denominator. I think this is the last part on the notes. To rationalize a denominator, what it means is you can't have a radical in the bottom. So I want to get rid of the radical. So what I'm going to do, 2 over the square root of 3. The way you get rid of this is we're going to multiply it by 1. You can't change the value, but how you do this is you're going to take square root of 3, square root of 3. Because technically, like x divided by x is 1, 9 divided by 9 is 1, square root of 3 divided by square root of 3 divided by square root of 3 is 1. Okay, so now as we multiply these, I have 2 square root of 3, right? I put these together, I have the square root, and you have 3 times 3. Well, 2 square root of 3, the 3's can come out and play, right? So that puts in the bottom a 3. You can write it like this, or that either way it means the same thing. Take a second and try that bottom one. On the bottom one, we're going to go and I'm going to multiply, or I'm going to take 5 times square root of 2. And I'm going to multiply it by the square root of 2 on the top and on the bottom. Okay, so the top becomes 5 square root of 2. The bottom, square root, and I have 2 times 2. The top stays the same. Then the 2's can come outside and play. So it's just a 2 right there. And that's as far as you can reduce it. Now you could, again, you could write it 5 over 2 times the square root of 2. Doesn't really matter. That's the same. Okay. One other thing I want you to add to your notes page, because you're going to need it for your assignment. Who remembers the formula for the Pythagorean theorem? A squared plus B squared equals C squared. Now, that only works on a right triangle. What marking tells you that it's a right triangle? The little box is going to show you that the angle, or that angle is a right angle, even if you can't draw like me. Now, the side opposite the right angle, the longest side is side C, the hypotenuse. And that didn't even look like a C over there, does it? Okay. That's C. Now you have A and B, and it doesn't matter which ones you call A and B. Those are just the legs. Okay? The biggest thing is to make sure you know which one is the hypotenuse. So let's look at, let's just do one for giggles. Does everybody have this written down? No? Yes? Okie dokie, here we go. Let's try this one. Again, don't mind my drawing. 15, 17, and x. Now remember, a squared plus b squared equals c squared. C is this 17. That's the longest side. That's the side opposite the right angle. It doesn't matter which ones you make, A and B. Okay, those are just the legs that go right here. So let's fill this in. First off, I don't know this side. That's a leg. So I have x squared plus the other leg is 15 squared equals 17 squared. Okay. All right, so I've got x squared plus, what's 15 squared? 15 times 15? 225? Don't look at me. Y'all got the calculators. Let's see. See, that's just an extraordinary brain right there. Okay, don't laugh. All right, 225. So I'm going to put plus 225. And 17 squared. 17. What is it? 289. Okay, so all I've done is taken 15 squared and 17 squared. How do you get x squared? What do I need to do in solving equations? Subtract 225 from each side. I get x squared equals, what is that, 64? X is going to equal the square root of 64. What's the square root of 64? 8 times 8 is 64, right? X equals 8.